Hi everyone. Vector subtraction is used to find the change in a vector. For example, if we want to calculate the change in momentum, then the change in momentum equals final momentum minus initial momentum. So how do we subtract vectors? To subtract one vector from another, we have to reverse or flip the direction of the vector you wish to subtract and then add this negative vector to the other vector. So for example, question A, let's determine the magnitude and direction of the resultant vector of 2 newtons north minus 4 newtons south. So minus 4 newtons south will become plus 4 newtons north. So we have to flip the subtracted vector. So 4 newtons south is the same as minus 4 newtons north, and minus minus will become plus. Okay, so here we have 2 newtons north plus 4 newtons north. And this question is the same as vector addition. So now we just want to add these two vectors. So let's draw the vector diagram. We have 2 newtons north, and then we have 4 newtons north. So connect these two vectors from head to tail, and the resultant is from the start to the end. So this is the resultant. So the resultant equals 2 plus 4, which equals to 6 newtons. And in this case, the direction of the resultant is upwards or north. So therefore, we can say R equals 6 newtons north. Question B, 10 newtons east minus 5 newtons west. So minus 5 newtons west will become plus 5 newtons east. So to change this sign from minus to plus, we have to flip the direction. West becomes east. North would become south. South would become north. West would become east. And east would become north, west. So therefore, we have here 10 newtons east plus 5 newtons east. So connect these two vectors from head to tail, and the resultant is from the start to the end. This is the resultant. So now let's calculate the resultant. The resultant equals 10 newtons plus 5 newtons, which equals to 15 newtons, and the direction is east. Okay, question C is 29 meters per second south minus 19 meters per second east. So we have to flip the subtracted vector. So minus 19 meters per second east becomes plus 19 meters per second west. So now we have 29 meters per second south plus 19 meters per second west. Okay, and now we just need to draw the vector diagram. The vector diagram, so we start with 29 meters per second south, okay, and then 19 meters per second west. So as we can see, we connect these two vectors from head to tail, and the resultant is from the start to the end. So the resultant is from the starting point to the end point. And in this case, we need to also find the direction of the resultant. So we have to calculate the value of theta. Okay, so what is R? In this case, we know two sides of the triangle. Then we can find the third side using Pythagoras theorem. So R, the hypotenuse squared, so R squared equals 19 squared plus 29 squared. And here to get rid of the power of R, okay, to get rid of this squared, we have to square root the other side. So R equals the square root of 19 squared plus 29 squared. So when we square root the other side, we have to include the plus and the minus sign. But in this case, we don't want the negative answer because the side of a triangle cannot be negative. So we will just consider the positive value. So the square root of 19 squared plus 29 squared is equal to 34.7 meters per second. And now we can find the value of theta. In this case, theta is located here next to the tail of the resultant. We know the opposite side is 19, and we also know the adjacent side is 29. So in this case, we will just use the tan ratio to find the value of theta. Okay, so theta equals tan inverse. Opposite is 19, adjacent is 29. And we get 33.2 degrees, correct to one decimal place. And this angle starts from south, so we have to say south, 33.2 degrees west.